Okay, so we're doing cross-sectional volume. Today we're going to be doing it with isosceles right triangles. Okay, so it says find the volume of the area bounded by these equations when the cross-sections are perpendicular to the x-axis. They are isosceles right triangles with a leg in the xy plane. So again, I always tell my students the best thing you could do is to kind of draw a picture. So we've got the quadratic right here that's been moved down one. So it looks something like this. And then we have this linear function of 2x minus 1, which basically y-intercept there, slope of 2. So it looks something like this. Okay? As soon as I see that our cross-sections are perpendicular to the x-axis, I know I'm using this volume equation. Volume equals the integral from a to b, a of x dx. Okay? So I got to figure out my area equation. Well, my cross sections are isosceles right triangles. So based on what we did the other day, the base equation for that is 1/2 base squared, using the triangle equation and the base being on the xy plane. And my isosceles right triangles are going to look like this, where here's my leg, there's my 90, like that. Okay? So this side right here is my base from here to here. So I need to know what that base length is. Well, since it's vertical like that, I know the equation I can use is it's going to be my function on top minus the function on bottom. Therefore, since I've already got this nice picture, I know that my linear function is the function on top, so it's going to be 2x minus 1 minus the quadratic. And when you simplify that, you get 2x minus x squared. That is my base of my triangle. Then using that equation, we can plug it into my area, which means my area equation is going to be 1/2 of 2x minus x squared squared. And then we can plug that into my integral, giving me my volume equation. I'm going to put the 1/2 out in front to make my life easier. 2x minus x squared squared dx, like so. Now all I need to do is find my limits. Okay? Now I know one of my limits is going to be 0 already because they intersect. They both have that 0, -1 point in common. To find the other one, I need to set them equal to each other. So 2x minus 1 equals x squared minus 1, which means 0 equals x squared minus 2x. And then you factor and you get x and x minus 2, which means your zeros or your interception points are x equals 0 and x equals 2. So those are my upper and lower limits, so 0 and 2. Now that we have my volume equation set up, now we're just dealing with another definite integral. Okay, so first thing I notice though is I got a function inside of a function, so I either have to do u substitution or I take the time and I FOIL this out. So it'd be much easier to FOIL this out. So I get 1/2 the integral from 0 to 2 of 4x squared minus 4x cubed plus x to the 4th dx. So you got to FOIL that out. You got to do 2x minus x squared times 2x minus x squared. Don't you dare sit there and distribute in the squared into your parentheses. It's not how it works. Now, take the antiderivative. So I get 1/2 times, this is going to be 4x cubed over 3 minus, this is just going to be, I'll simplify it at the same time, this is just going to be x to the 4th plus x to the 5th over 5 from 0 to 2. So the good news is I'm only going to have to plug in one of the limits, because when I plug in 0, I'm going to get 0. So that makes my life a little bit easier. So we plug in 2, so we get 1/2 times 4 times 8 over 3 minus 16 plus 32 over 5 minus 0. And then we simplify. So when we simplify, we're going to get 16 over 3 minus 8 plus 16 over 5. And then to simplify, we get common denominators. So our common denominator is 15. So this ends up being 80 over 15 minus 120 over 15 plus 48 over 15. And 80 plus 48 is 128 minus 120, which gives us 8 over 15. And that is our volume. Now, I do want to show you guys one thing. If I had done this problem, I said, instead of saying, hey, find the area or volume of this cross-sectional volume, if I had just said find the bounded area of my two functions, if I said, hey, we're not going to do volume, all I want you to do is find this area, our equation would have been almost identical. Our equation to find that bounded area would have been the integral from 0 to 2 of 2x minus x squared dx. That's the equation for finding the bounded area that we use to find the volume. So you can see how this directly links to what we have just been doing with bounded area. And that's why I do cross-sectional volume first. A lot of teachers will do rotational volume first and then do cross-sectional. But since basically the bounded area equation leads you straight into your cross-sectional volume, it makes more sense to do it that way. Okay? Your code for today is going to be W33K3ND.